If I'm giving you two functions and I say, hey, are these inverses of each other? Here's what we can do. We can find the composition of my function and its inverse, and the composition of the inverse and the function, and they must equal to the identity element, x, for every member. If they equal to anything else besides x, then they're not inverses. So let's check that. Let's take a look at example 5, and I want to know, are these inverses? So if I go, I'm going to find f of g of x. So in other words, I'm going to say 6 all over g of x minus 4. So now I'm going to replace g of x with, so I got 6 over x plus 4 minus 4. And I got a complex fraction there, so let's get rid of my complex fraction. And first of all, 4 plus, I'm going to simplify 4 minus 4. That's 0, isn't it? So I've got actually 6 over x. I'm going to multiply my denominator by x and my numerator by x. So I'll get rid of my complex fraction. So what happens is we get 6x over 6, which is x. Well, that's good. That's my identity function. Now let's turn around and let's find g of f of x. So I'm going to find g of f of x. Now, if I got something besides x for my first one, I won't have to check the second one. But so now I'm going to say g, which is 6 over, I'm going to say f of x plus 4. So then I'm going to say 6 over x minus 4 plus 4. Okay, once again, I've got a complex fraction. So what I'm going to do is I'm going to multiply numerator and denominator of my complex fraction by x minus 4. I'm really just multiplying by 1. So then we get 6x minus 24 all over 6. I guess I should have not multiplied that out. So I'll go plus 4. Now I'll simplify that. So I get x minus 4 plus 4. And then x. So yes, these are inverses. Now, how do I find the inverse of a graph? Okay, we've done it algebraically. So now I want to look at the inverse of my graph. So what I'm going to do is I'm going to look at my graph. I'm going to pick some points. So notice I'm going to pick 0, 0 here. I'm going to pick, let's find, over here we've got the point 1, negative 2. I've got one x-intercept. That'll be at 2, 0. I've got the point negative 1, 2. And my other x-intercept will be negative 2, 0. And then maybe I could pick some points to the left or to the right. Now, when you find in the inverse, I'm going to just do the inverse in a different color. And remember, we're finding the inverse, we flip the x's and y's around. So in other words, 0, 0, that doesn't change, does it? That stays exactly the same. Now, I'm going to take a look at my other points in here. So I'm going to use this point, which is at negative 2, 0. So in other words, it'll be at 0 and negative 2. And then I'll take a look at another point here, which is at negative 1, 2. So they'll be at 2 and negative 1. Then I will plot the point. I got 1 and negative 2. So I'll go negative 2 and 1. And then finally, I'll do my other x-intercept, which is going to be at 2, 0. So I'll do 0 and 2. Now what I'm going to do is I'm going to graph my function. And by connecting my points. And so what happens here, I'm going to flip it over the line y equals x, but I can actually just see this from right here. So I'm flipping my line around, so it's going to go like this. And there's our inverse to the best of our ability. What I did is I took that and I reflected over the line y equals x, but I just plotted my points, and then I've got my answer. To the, not an artist, but we get the kind of the idea there.